Okay, we're going to talk about 4.7 piecewise functions and step functions actually as well, which is just a special type of piecewise function. So let's go ahead and start with some vocabulary. Piecewise function is where two or more equations where each piece of the function applies to a different part of its domain. And remember, domain is measured by x value. Domain, it's talking about, it's interpreted through our x-axis. Whereas a step function is a special piecewise function with a constant value for each part of the domain. So for instance, if I had a quick picture here, try that again here. I had a quick picture. Let's say I have a step function or a piecewise function that is something like this. It rises to that point, and then from there it flattens out, and then let's say go ahead and rise again from that point. Okay, that could be a piecewise function. In fact, you know what? Let me switch that last part up just to make it a little more clear. Okay. That would be a piecewise function. Notice your line has been broken into different parts, and those parts are, we talk about where those parts are broken apart by using the x-axis. So the line breaks here on x and here on x. Okay, and I'll show you that here in an example. So I just wanted to see a picture. But a step function more has, let's say, like a straight line approach to it. So these would be constant equations. So for instance, if this was 1 and this was 2, maybe 3 here, and so on. Okay. Notice you get these things that look like steps, kind of floating steps. That's a step function. That's what the pictures look like. Okay, so let's try some of these out, like using equations and stuff. Okay, evaluating piecewise functions so that we actually know what we're doing here will be helpful when prior to us actually graphing some of these. So first thing I'm going to do is I'm going to look at this and I say, okay, evaluate the function f when part A, x equals 3, and part B when x equals 1. So what you need to do is you need to look at the rule. So this is saying f of x is equal to this set, negative 2x minus 1 if x is less than or equal to 2, and it's equal to negative x plus 4 if x is greater than 2. This is a notation where you have this bracket here. Anytime you use multiple equations, usually bracket them together. You think of this bracket as kind of holding those equations together. Okay, so anytime we have more than one equation, when we do systems, you can bracket them together as well. And notice I don't have one on the right-hand side. It's not because I forgot. It's just you only put one on there. Okay, so using this piecewise function, I need to evaluate when x is 3. Well, notice x equaling 3, I have two choices here. I could clump that into the first set where it says x is less than 2, or I can clump it into the second set where it says x is greater than 2. Well, notice x equals 3. Well, 3 is greater than 2. So we need to put this, in this case, x is greater than 2. Which tells me I have to use this rule. There's the rule. I'm using negative x plus 4. And what exactly does that mean? That means you put the 3 in for x. We end up with, positive 1. So that would mean f of 3 is equal to 1. Okay. Now note on this next one, since x equals 1, well, x is less than or equal to 2. In this case, it's less than 2. So I need to use the top rule, negative 2x minus 1. I'm going to use negative 2x minus 1. So I'm going to plug the 1 in, or substitute the 1 in for x. And that gives me negative 2 minus 1, which is also known as negative 3. So f of 1 equals negative 3. Okay, so that's how you evaluate piecewise functions. Now let's go ahead and try to graph some here. All right, and I'll do my best to make this so it's easy to understand. But the first thing first thing to recognize is you once again have two parts. You have x equals, or x is less than or equal to 2, and x is greater than 2. So I'm going to go over to my graph, and I'm going to just kind of mark where x is 2. And that really separates my graph into two different chunks. It separates, let me go ahead and highlight that. It separates into this chunk right here, where x is greater than 2. Okay, all this over here to the right side of 2. Okay, so over on this side, if you're looking at the x-axis, all of those values on the x-axis from here over are greater than 2. Okay, and then I have the part where it's less than 2. So if x is greater than 2, I'm using the equation. Let me go ahead and keep that highlighted up there for a minute. I'm going to go ahead and use the equation x plus 4. And when x is less than 2, so over here in the non-highlighted part, I'm using the equation negative 2x minus 1. All right? And so what I need to do is I need to graph both of those lines. So the first one's easy. I can look at it and go, okay, well, for this part, y equals negative 2x minus 1. I can say, well, the slope is negative 2, and the y-intercept is negative 1, thinking y equals mx plus b. Okay, so that means my y-intercept here, negative 1, and I go down 2 and over 1, and down 2 and over 1. Okay, and down 2, and well, now I'm into the yellow. And this graph doesn't go into the yellow because of my domain here. It's saying x is less than or equal to 2. It only exists on this side of 2. So that means I'm going to continue my pattern the other way, so I can get the rest of that line in there. Okay, now if you have a straight edge, it's best to use that straight edge. I have one here that I'm going to use. Whoop, didn't mean to do that. There we go. Okay, and I should stop right at that point right there. All right. And then I have this other part, y is equal to x plus 4. And my slope here is 1, and my y-intercept is 4. So I'm going to put 4. Now notice, when I put 4, I'm not in the yellow area like I'm supposed to be. I'm going to rise 1, run 1. Okay, and I need to only be in the yellow area. So the only points that I'm really, really concerned with here are the ones in yellow. Okay. So, oops. I'm going to stop right there at the edge of yellow. These points right here don't matter to me. They were just there to help me see where that line was. All right. Now, recall, oops. This right here, this symbol, means that any value of 2 would also make this statement true. 2 is equal to 2. So this is a closed circle on a graph. Whereas this value, if I put 2 in here, 2 is not greater than 2. So those values do not work. So this is an open circle on a graph. Okay, so 2 would not be a solution. So for the highlighted part where it hits the x is 2 line, so right here, this has to be an open circle. Okay, now I know I have a dot there, and I'll try to do my best to erase that without erasing my whole line, which I just did. Well, we'll try to fix that line. Okay, there we go. And then the bottom one right here has a closed dot because of the equal to piece. Okay, the only thing I haven't put on there right now are arrows. And those arrows are going to help me to describe the domain and range. Okay, now notice this graph for the negative 2x minus 1 does not go past the yellow here, so it stops, but extends upward forever. In this graph, the yellow x plus 4 does not go out of the yellow, but it extends upward forever as well. So notice neither of those graphs are going down. They are going, and I like to show this using arrows, just kind of off to the side. This graph is going up and to the left. That's what this arrow means. It's going up and to the left. This arrow is going up and to the right. We don't have any arrows going down. Okay, notice the arrow is extending left and right, and everything in between these is taken care of. Each x value has a solution for it in between these lines, including the 2. Okay, therefore, my domain, now remember domain represents x. My domain x is equal to all real numbers because it extends to the left and to the right forever. Okay, and we can write that as an R with an extra line in there, all real numbers. Now the range, remember, stands for y. Okay, and notice y is an axis that goes up and down. Okay, well this is going up, this is going up, there's nothing going down, which means there will be a low point to your graph, and the low point just happens to be right down here, the lowest point on the graph. And that is right there, and that when you draw it over to hit the y-axis, it's at -5. And it goes up from there. So y is greater than, and since it's solid dot, or equal to -5. There are my domain and range, and my graphs. I'm going to write a piecewise function, okay, for a graph. And so the first thing I'm going to do is I'm going to look at this graph, and I'm going to see where it's broken apart. So notice my line goes fine here, and then it breaks right there. And then it goes down, and then it breaks again and goes to another spot. Okay, so what I have are 3 parts. I have this part here from -4 down. I have from -4 to 2, and then I have from 2 over. Okay, in fact, I'm going to go ahead and highlight it. I'm going to highlight this section in the middle here. Okay. All right. Now, it may just seem that I like coloring. However, the highlighted marks will help us out tons here. And they kind of help us to see. So, highlighters might help you out if you got one. And I'm going to go ahead and extend that highlighting mark up above so I can kind of make some notes and highlight it, and down below here. So I can continue to make some notes for us. Okay. So, notice from here, I now have this chunk right here where it's broke. It's broke on this side. X is at -4. It's getting smaller. And it has an open circle, so no equal to. And then over here, we have X is at 2, and it's getting bigger. Okay, it's going this way on the x-axis. So I'm measuring all this on the x-axis. So at -4, we're going this way in this white area. At 2, we're going this way to the right, which is greater than. Okay, and then here in the shaded area, this is between -4 and 2. So X is literally between, let me go ahead and write this up here a little further. X is literally between -4 and 2. Okay, it's less than -4, or it's greater than -4 and less than 2. Okay, and so that's how we write it. And those arrows will always point to the left when you're doing it like that. So, okay, and so if it helps you to see that still highlighted, then go ahead and, whoa, well, don't highlight like that. That's ridiculous. Okay, highlight using yellow. Okay, they can actually see it. All right, so there we've got it. So now you can go ahead and try to write some of this stuff out in terms of an equation. So notice when we're at -4, okay, so I'm going to go ahead and set my rule. X is going to be less than -4, and I'm going to kind of work backwards. Okay, so the equation I'm using, if X is less than -4, well, that's an equation right here, and really it's nice if you can see a straight edge, but I'm going to just kind of draw where my straight edge would show me. So if I lined up a straight edge along this line and measured over I would see that my graph would hit right there at 2. So I would have a y-intercept, m would equal 2. Okay, in fact, let's write that below so it makes it a little easier. I'm going to go in slope-intercept form. So m equals 2. Not m, b equals 2. My y-intercept is 2. My slope is 0. Okay, so my equation here is y equals 0x plus 2. So think y equals mx plus b. So y equals mx plus b. And 0x is just 0. So y equals really 0 plus 2 or 2. So we're using the equation y equals 2 if x is greater or less than negative 4. Okay? So if x is between negative 4 and 2, so our shaded area, then we're going to use the equation. Well, let's go ahead and look at it. M is, in the shaded area, m is going to be, oh, it looks like our slope is negative 1. And our y-intercept is, well, looks like it crosses at negative 2. So my equation, y equals negative 1x minus 2, or simplified y equals negative x minus 2. Okay, so once again, that's in our highlighted area, so if you need to see all that highlighted, I was trying to keep all that. Okay, so we could say, well, over here, y is equal to negative x minus 2. Okay, and then over here we have the rule x is greater than 2. Okay, I should read if there. If, and, well, we have an equation again here. Oops. Go and see our slope. Looks like it's rise 1, run 1. Our y-intercept, well, if we extend this line again, looks like it would hit at negative 6. Now, once again, if you have a ruler, it's nice. We can see that. Crosses at negative 6, so we have y equals 1x minus 6. Or y equals x minus 6. There's our rule. Okay? Well, the last thing you really need to do is you need to bracket this and get rid of these y equals, because we usually don't put the y equals here. Remember, we put a big old bracket to hold it together, and we say f of x equals that. There is our piecewise function. All right. Let's go ahead and talk about the step functions. Okay, so you rent a bouncy house for 5 days. The rental company charges $75 for the first day, $50 for each additional day. Write and graph a step function that represents the relationship between the number of x days and the total cost, y dollars, for renting a bouncy house. Okay, so the first thing I'm going to do is I'm going to make a quick table. And I'm going to have x, remember that's our days, y, that's our dollars. Okay, and I know for 1 day it's going to cost $75. I know for 2 days, well, the next day is another 50, so 75 plus 50, 125. 3 days, we had another 50, so 175. 4 days, we had another 50, so 225. And 5 days, so we're renting it for 5 days, we had another 52, so 275. So this is going to help me figure out my scale. Okay, so here's 1 day, 2 day, 3 day, 4 day, 5 day. It looks like going up by 1 on x, which represent days. Okay, or number of days. Excuse me there. Okay. And then on the y-axis, I would have dollars. Okay, or total cost in dollars. All right, and probably, I'm going to go up by 50s. So 50, 100, 150, 250, 350. Okay. So now I know for 1 day it's $75. Well, really for anywhere between any part of the first day, so 0 to 1 days. If I have an hour or 24 hours, it's going to be $75. So I'm going to start right here with an open circle at 0, and then go to when the number of days is 1. For 1 day with a closed circle, 75. Now, for anything greater than 1 day, but less than 2 days, okay, less than or equal to 2 days, it's going to be 125. So if I take it from anywhere bigger than 1 day and go all the way to 2 days, I can get it for a full 2 days for 125. Or I can get it for, so like 48 hours for 125. Or I could get it for, say, 1 day plus another 2 hours. Still cost me $125. Okay? And so I can kind of do the same thing here for 3 days. I'm at 225. And for 4 days, I'm at 3 days, that's 175. At 4 days, I'm at 225. And at 5 days, I'm at 275. All right. That's a step function. Notice you see your steps there. Okay. Now, in terms of writing this, we'd have f of x is equal to, and I'm going to put a humongoid bracket. Okay. And I know it's equal to 75 if it's going to cost me $75 if the number of days x is between 0 and 1. Greater than 0, but less than or equal to 1. And it's going to cost me $125 if x is between 1 and 2. Greater than 1, but less than or equal to 2. It's going to cost me $175 if the number of days x is between 2 and 3. Greater than 2, but less than or equal to 3. It cost me $225 if the number of days x is less than 3, or greater than 3, but less than or equal to 4. And finally, $275 if the number of days x is greater than 4, but less than or equal to 5. So you can get it for a total of 5, equal to 5, for $275. All right. There we got it. That is a step function. And we graphed it, and we wrote the equation there. All right. Last piece is a piecewise function for an absolute value. The first thing we need to remember what an absolute value looks like. Okay. So an absolute value is a V shape. And just based on looking at it, you can tell that it broke right there. So our line's been broke. So now you can kind of see it as a piecewise function. Now you know what it looks like and what a piecewise is. So absolute values were in the form of a times x minus h plus k, where a was kind of like a slope, and hk is our vertex. Okay, h and k. So we think of our vertex hk. So when I'm looking at an equation or a function, h of x is equal to 2 times x plus 4 and plus 3, I first want to find my vertex. Remember, the vertex is that turning point. Okay, so vertex is also right there. Okay, so the vertex of this one, our h value, well, notice this says x minus h and this says x plus 4. So my vertex would actually have to be, if we put it in minus form, so it would be minus a negative 4 plus 3. So my vertex is actually negative 4, positive 3. Okay? So what I could do now is I can plot the vertex. It's at negative 4, positive 3. And that also helps me because that shows me that's where my graph's going to turn. So remember, this is like a slope, like a rise and run. And rise and run in this case would be 2 over 1. So as I'm going out of this, I'll go up 2 and over 1, up 2 and over 1, up 2 and over 1. Okay. So I have a line that does that right there. Hits all these points. And then up 2 and over 1 this way, they just reflect over. Okay. And so I have a line that goes the other way also. Now, those lines are really poor. Now, like I said, you should really find a straight edge that will work well for you. So I'm going to go ahead and use mine. Okay. All right. So there's my absolute value function. Notice it turns right here at -4. So if you call like us highlighting a piece, well, that means, let me go and use a color we can see through. Oops. Did not mean to do that. There we go. Okay. Let's go ahead and, so from here over, kind of highlight. All right. Once again, I'm not a big fan of coloring. However, it does help on these. Okay. So there you've got it. So when I'm looking at this and trying to figure out how to write this out, I can say, well, my piecewise function is going to be f of x is equal to, it looks like it's broken up at -4, so a place where x is greater than -4, and a place where x is less than -4. Okay, so if I'm kind of setting up these rules, less than -4 and x is greater than -4. Okay, if once again, I kind of work backwards. Okay, and so I can look at it and say, well, this equation, the equation of this line, I'm going to go ahead and kind of extend it. So go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So notice if I were to extend this line out, it would hit the y-axis right there at -5. So this side, the non-shaded, would have a slope of -2. It's going down 2 and over 1, and a y-intercept of -5. Okay, so that's if we were to extend it. So that means that equation is y is equal to -2x minus 5. And that's the equation when it's less than -4. Now remember, we don't actually put the y equals. Okay, and so this one, it's a little easier to see in the shaded area here. So we have a slope of 2. We were rising 2 and running 1. And then a y-intercept, it looks like we're going to go, right here is 9. We go up 2 and over 1. It looks like it's going to hit at 11. Okay, so we're going to have the equation y equals 2x plus 11. All right. So there is a closed dot at the vertex. So that means that -4 is a solution, and both of these say -4 isn't. So we've got to make one of them an equal to, and I'm going to put it on here at the bottom one there. So x is greater than or equal to -4. So we have that solid dot right there. Okay, well, that's all I've got for you. Good lucky.